take that a step further and actually talk about not just the slope, but what's the other thing that we've been doing with derivatives? Finding the equation of the line that's tangent to the curve at that point, right? Okay, so example 2. Let's say we've got the equation x squared plus xy minus y to the third equals 7. And we want to find the equation of the line tangent to the curve at the point 3, 2. Now on this one, since y appears in more than one place, it really doesn't help us to try to like move things over. We can take this one that's just got an x squared and get it out of the way. So I've got xy minus y to the third is equal to 7 minus x squared. I can at least do that. So, yes. No. So let's talk about that. Let's take the derivative of each part. This is a product, so I've got to use the product rule, right? So I've got the derivative of the first, which is 1, times the second, plus the first times the derivative of the second, and the derivative of y is dy dx. So it's 1 times dy dx minus the derivative of y to the third is 3y squared dy dx is equal to, the 7 goes away to a 0, negative 2x. So, now the next step on this, remember, at this point we have taken the derivative. It's just not solved for dy dx. So we're going to solve for dy dx. So you look at every term that's actually got a dy dx in it, and everything that doesn't, move it to the other side. So this 1y needs to go to the other side by being subtracted. So I've got x times dy dx minus 3y squared times dy dx is equal to negative 2x minus y. Once I get it to this step, then I'm going to factor out the dy dx. Just kind of pull it out in front. Now, in this term, when I factor out, it means I divided it out, right? So if I factored out the dy dx, what's left? X. And if I factor dy dx out of the second term, what's left? 3y squared. Okay? Now what can I do to get it solved for dy dx? Divide by that thing I just said was left over after I factored it out, right? So, dy dx is exactly equal to negative 2x minus y over x minus 3y squared. Now, that's the derivative. What were we shooting for here? We want the equation of the tangent line. So what do I need to find the equation of the tangent line? I'll need an x and a y, and they gave that to me. That's at this point 3, 2. So here's my 3, 2. That's my point. And what else do I need? And I need the slope. Okay? So how would I find the slope? Plug the 3 and the 2, right? Everywhere there's an x in the derivative, I'm going to put in a 3, and everywhere there's a y, I'm going to put in a 2. Remember that that's the difference. For me to be able to find this slope, I've got to evaluate dy dx at this point. and it's going to take both of the coordinates. So I've got negative 2 times 3 minus 2 over 3 minus 3 times 2 squared. So everywhere there's an x, put in the x value. Everywhere there's a y, put in the y value. Yep. Order of operations says I must do the exponent first. So I get negative 6 minus 2 over 3 minus, and this gives me 4 times 3, which is 12. Remember, do order of operations. Exponents come before multiplication. So I get negative 8 over negative 9, which is 8 over 9. And that's my slope. So now I have a slope and a point. What can I do? So y is equal to 9 over 8 times x. Okay, did I say it wrong? 8 over 9 times x minus 3 plus 2. Putting it in the point slope form of equation. And then you get 8 over 9x minus 24 over 9 plus, I'm going to turn that 2 into 18 over 9, right? So that I have a common denominator. So y is equal to 8 over 9x minus 6 over 9, which is 2/3. If you want to reduce it even further. Same idea. Nothing new here except for the fact that you have to remember that because you can't solve it for y. See, always before it was y equals. And so we always said that was dy, right? dy dx, because y turns into dy dx. But now I've got things that I've got more than just dy dx. We can also find second derivatives or higher order derivatives. Same thing here. You just do first derivative and then you do the second derivative. So let's find the second derivative of y with respect to x twice. That's what that means, finding the second derivative of y with respect to x twice. So I've got x squared plus y squared equals 1. Okay, move the x, so we've got y squared is equal to 1 minus x squared. The derivative is 2y dy dx is negative 2x. Excellent. So dy dx is equal to negative x divided by y, right? Because the 2 cancels out when I divide both sides by that 2y. Now what do you do? You just do it again, just like you've always done. So the derivative of this is the second derivative of y with respect to x twice. But now this is the quotient. So I got to use the quotient rule, right? How about low d high minus high d low over low squared. Okay, well now hang on a minute. I can't leave dx in it. Nope, because I don't have to. I know what dy dx is equal to, right? Yeah, that's right. So the second derivative of y with respect to x twice is negative y minus negative x times dy dx is negative x over y squared. if it's not true, then we're in trouble. Oh, I wrote the negative down twice. Minus 6. Sorry. Is that? I don't think so. I'll put it back there. Because I put it in the top, and I probably should have put it like out in the front. It'll work. I was just thinking we're going to make everything positive here in a second. All right. Let's look at this. So let's simplify it a little bit more. So I've got negative y minus x squared over y squared. Yes? So I got to get this together so that I can make it not be a complex fraction. So I need a common denominator. So that's going to become negative y squared over y minus x squared over y. We good with that? Gave it a common denominator. Right. Over y squared, which is the same thing as multiplying by 1 over y squared, right? Because I can flip it and bring it to the top so I don't have it in a complex fraction anymore. So if I factor that negative 1 out in front, I got negative 1 times x squared plus y squared over y to the third. Now I got a reason for having turned it around like that and pulled the negative 1 out, because I know what x squared plus y squared is equal to. I said it was equal to 1 at the very beginning, so I can replace, anytime I get that function, I can replace that with a 1 for this problem. So I got negative 1 times 1 gives me negative 1 over y to the third. Second derivative works the same principle, but it's a little more complicated because you do have to do the substitution as you work your way backwards to get it in simplified form. Any questions? Example 4.